So in graphing linear functions 1, we call it the long way because we were asked to graph it in this domain from -3 up to +3. What about if we looked at two different quick ways to do it? So the first way is to find where this function, and you can see it's a straight line because it's just x to the power 1, where it crosses my x-axis and my y-axis. Let me just put my y in, and over here normally put my x on the right. So if x is equal to 0, that means that there's a point along the y-axis, which I'm coloring green. Along the y-axis, there's a point somewhere here that represents this function. So if x is 0, you can see all that's left is the +2. So the function is equal to 2. And as we've seen before, f of x is equal to your y value. F of x and y are the same thing. So what about if y was 0? So what would we have to put into here to make this equal 0? We'd have to put x to be -2. So we have the point 0, 2. So now we're going to put the scale on the diagram. I'm doing it in red, so highlights a bit better. So we want 0, 2. So what I'm going to do is I'm going to just jump out every 2. So I'm going to say 1, 2, and 1, 2. I'm going to go back as well. 1, 2, -1, -2. And again down 1, 2, -1, -2. So where are my points? 0 on the x, 2 on the y is here. And -2 on the x, 0 on the y is here. So this is the graph of this line. You would use a ruler and get it exact. And we're asked to do it between 3 and -3. So just put a 3 on and a -3 on. And we have it done between 3 and -3. We could close it off if we wanted. If we just wanted to graph it between 3 and -3. Just continue this one up a bit. Just up here. Crosses there. That'll be 3, 4, 5. And if we put 5 in, or we put 3 in for x, we're going to get 5 for y. So this is the point 3, 5 up here at one end. And the other point at the other end is -3, -1. You can see if you put -3 in for x up here, you're going to get -1. So that's the quick way. Just get the either the endpoints, the 3 and the -3, or the 2 points where it crosses the axis. So that's the two quick ways to do just graphing a function when you know it's linear. Now let's look at the second one. So if x is equal to 0, y is equal to 4 here. If this is 0, all that we're left with is the 4. And if y is equal to 0, what do I have to put in here to make this whole thing 0? Well, if I put 2 in for x, I'm going to get -2 by 2 is -4, plus 4 is 0, so x will be 2. So the points 0 on the x, 4 on the y is up here, and the point 2 on the x, 0 on the y is down here. And if I connect my points, it looks like I got a point of intersection here. So what about with algebra getting the point of intersection of these two lines? And we'll see, does it match up to our graph? So we have f of x is equal to g of x. These are all the things that can be asked within these questions. So this is a really simple one. X plus 2 is equal to -2x plus 4. Bringing the 2x to the left, the -2x becomes plus, so we get 3x. And the 2 to the right becomes -4 minus 2 is 2. So x is 2 over 3. And if x is 2 over 3, y is equal to, well, it's just 2 plus 2 over 3, 2 and 2/3. So is this the point x is equal to 2/3? Approximately there. Y is equal to approximately there, 2 and 2/3, and you can see this point does match up here to pretty much what we were saying, that x is 2/3 and y is 2 and 2/3. I'm just going to call this the POI, the point of intersection between the two lines. A question that you've seen before, just called simultaneous equations. But here it is, graphing two linear functions, finding the point of intersection between them using algebra. A great question. If you can master this question, you can master anything in mathematics.